A warm welcome to everyone. So I hope you are all having a very good time at KubeCon. And today I'll be talking about a bit about ClusterAPI and Systemd-Sysext, something we have been working on at the Flatcar Container Linux team. So, and I would like to share our experiences on how we are trying to change a few of the architectural changes that are there in ClusterAPI. So before starting off with the talk, I would like to share a bit of an agenda. So in the beginning, I would like to set some context for everyone. So if folks don't know about ClusterAPI, I'll give a very brief introduction about ClusterAPI. Then moving on, I'll be giving an introduction about what is Image Builder, which is one of the core components of ClusterAPI. And then I'll show you on how ClusterAPI and Image Builder currently works. And then I'll be introducing you all to Systemd system extensions. And finally, I'll be showing on how we are utilizing system extensions to on ClusterAPI. So let's move on. So hello, everyone. I am Sayan Chowdhury. I have been in the community for a very long time, been doing open source work, but currently I have been working on Flatcar Container Linux since 2020. I primarily look around the releases and have been working on a lot of items around like package updates and stuff. I actually gave a talk yesterday on how we are working on and have evolved Flatcar over the last few years. And so I work within the Azure team in Microsoft. And with that, I would like to start off with the talk. So as I mentioned, let's build some context first. So let's talk about ClusterAPI. So ClusterAPI is primarily a way to set up your clusters. So in Kubernetes, you probably would have been using all the components of Kubernetes, but then when you interact with different clusters, there is definitely a pain point that comes into the picture, and that is what ClusterAPI is trying to solve. So you interact through ClusterAPI with all the cloud providers in the picture, so they be it like Azure, AWS, and others, and this is something how it looks. So as an admin, when you have a declarative configuration, you just like you use for Kubernetes, and you spawn up a management cluster to build up your workload cluster. So in the scenario, what happens is that so right now what happens is you have Flatcar running in all your workload cluster and the management cluster, but there is a problem that comes with Image Builder. Now, as a distribution maintainer, one of the heavy workloads that we have to do is we have to maintain a lot of packages, and then when we do releases, we have to update all our image build that is built to various cloud providers. And one of the things that we do right now is also update all the images for ClusterAPI. Now, for Image Builder, what it does is that it basically creates a image for the ClusterAPI. So, for example, like if you have an Ubuntu image and you have a Kubernetes release, say x.y. So, what a distro maintainer would do is, or the ClusterAPI maintainer would do is, they would build an image. They would take the stock image, they would take the Kubernetes release, and they would plug it both into the image builder, and then they will spill out a very distro-specific CAPI image. So what happens is that, so for example, as I mentioned, if you have like suppose 1.31 as a Kubernetes release, and we do a Flatcar release, which is for example 4000.0.0. So for the 4000 release, we cut out a new CAPI release, and the next time, and given Flatcar releases every 2 weeks, so we would have to do the same thing after every 2 weeks. Now, the problem that it arises here is that we end up having a lot of packages. So this is something I was looking into yesterday. So this is from the makefile of Image Builder. So you have like build AMIs, Amazon 2, CentOS 20.04, 22.04, and then you have Flatcar as well, and various others distros out there which are supported. Same goes for Azure. So you have, for Azure, you have CentOS 7, Mariner 2, Azure Linux 3, We have Flatcar Gen 2. So there, at the end of the day, you can understand that we end up supporting a lot of images, and they are we are stored somewhere on the cloud. So they are incurring some cost. So, and also this also blocks the number of providers or OSs that one can support. Now, the other thing that I would love to talk is that when you are adding this number of images, one of the things that we face is maintenance perspective of things. So suppose we are having this number of images, and if there are issues in that scenario, what happens is we would have to ask people to go to that particular version of images. Now, let's talk about how we merge ClusterAPI and Image Builder. Now, so you have the ClusterAPI running, and then when you have a particular provider, for example, I take OpenStack, and when you are starting up ClusterAPI, you use the clusterctl command. So in that scenario, it picks up that particular OpenStack, for example, because I'm taking OpenStack. So it will pick up the OpenStack distro CAPI provider image and try to boot up the workload, the whole of the cluster setup on that particular cloud provider. And with that, this gives a small bit an example. Now I'll move on to explain on how we use Flatcar with ClusterAPI Azure right now, where at this point we started to understand what the problem was. So now this is how you set up. So you have all the variables setting up. If you see here, we have a Flatcar version that is mentioned as 36.02.2.2. So this is the Flatcar version. And then, 1 minute. And then you also mention when you are setting up the cluster, you also mention the Kubernetes version. Now, we go up to and set up the management and the workload cluster. So in that scenario, so you create a cluster using kind, and then you create a cluster. You do cluster init infrastructure Azure, and then you go into create your ClusterAPI cluster, which is where you provide the the Kubernetes version, which is in this command. Now, what happens is behind the scene is that this is a provider template that is there for ClusterAPI Flatcar. So if you see here, we have a gallery on Azure, which has a particular name attached to it. So this is something which I was talking of. So for every release, we create a new Kubernetes version. So for every Kubernetes release, we create a new image in the gallery, and for every during the release, for every Flatcar version, we create a new image. Now this is where things start to start to spill up. Now now I'll be talking about the drawbacks. So what are the drawbacks we technically see here? One of the thing is that it adds a big overhead of maintenance, because we are already burdened with the number of packages we are maintaining and the number of and to add new features into Flatcar. This definitely adds a big overhead on top of the maintainers for Flatcar, as well as if image is getting maintained by the ClusterAPI providers, then it puts a pressure on them to manage those images. The next thing is, like, you saw that how Kubernetes and CAPI are bound together, Kubernetes and the OS are bound together to the image. So anything, if there are things that needs to be changed, in that scenario, you have to do a build again and create a whole new image for it. And the version matrix just explodes from here. So you would have Ubuntu 20, Kubernetes 22, Ubuntu 20, Kubernetes 23, and then the list goes on, like for SUSE, RHEL, Flatcars, Azure Linux, and others. So it's just a never-ending list of images out there that people have to maintain and see on which image they would need to use. And the other problem that we start to see is that there is a issue with whenever there is a because Kubernetes is bound to the image, whenever there is an upgrade that is required, you would need to use the newer image, and there's no in-place update that is there for the images. And for every image, for every new cloud provider, for example, we need to add a new cloud provider to the matrix, we would have to spin again a whole new matrix for it. So these are essentially, at the end of the day, I would say that it essentially boils down to the number of images you get to see on the cluster API side. Now, what is the solution for this? So this is where the Systemd system extensions come into the picture. So I'll give you a brief intro on what is Systemd system extensions. So it's an image-based Linux OS extension, so which primarily merges into like the USR and the auth partition, which so it's just like a file system image that gets created. And this was shipped very recently in Systemd. I guess right now the version for Systemd that is getting shipped is 256, and the version it got released was in 241, which is which was released in July 2021. And if you look through the work that has been going on in the last few Systemd releases, you would see a lot of work has been done around the system extensions, and there is an exclusive group also that got created called UAPI, where different distros are working together to make system extensions better. And there also is independent update concept using sysupdate, which we heavily use and is used in updating the in updating the system extensions. Now, this is how it primarily looks. So for example, you have a root file system. So in Flatcar, the USR partition is read-only. So you cannot really write things onto the USR partitions. And this brings a couple of challenges into the picture. So if folks needs to use something, they either use a container image, but these days we suggest them to build up a system extension, which is like image which contains the binary that is needed, and you can do a Systemd merge, system extension Sysext merge, and it would result into a file system that would provide all the binaries. It would place the system extension on top of the read-only file system and give you the binaries as like a normal Linux operation. So once the overlay is done, you will feel like it's just like a normal Linux command. So now, how we use Flatcar is that we provide two types. There are two types of way we support Flatcar. One is like the official images. So we at Flatcar support the Docker, Containerd, and the OEM, like the cloud specific. For example, Azure would need a OEM to run their agent, or for AWS there would be some agents. So those are the OEM which we do it via Sysext, and then there are other which are like the Podman or Python, ZFS, and others. We are introducing new images as they go. And the other one is like the community supported, where people are building their own system extensions via Sysext Bakery, which I'll show in some time. Now, the official images are built during the release of a Flatcar. So I'll also show that in a while. But the community ones are also created once in a while. We cut out a new release, and you would have the new system extensions created. Now, this is a look of how the repo looks like. So it's under the Flatcar org. And so if you notice here, there is a bake.sh. And there are a couple of system extensions. So if you open this particular link up, you will see there like probably 30, 40 system Sysext out there. And they're essentially, how do you say this? But they're essentially script files which picks up the tarball and places the binary on the file system, and you create like you do like a squash, make squashfs or mkosi to create the Sysext. Now this is what we do. Like we use the bake.sh. If you are using the Sysext Bakery, you can probably use the bake.sh. We have a documentation around it as well. Now this is for the community supported one. So folks who are using Flatcar and want to extend it, but there is no official support. They tend to create PRs on the Sysext bakery, or they also can create their own Sysext bakery on their own profile as well, because at the end of the day, when you are booting the system, it would pull the Sysext system extensions through an HTML, through a URL. So it will create an image, and you can just download the image and install it. And the next one is the officially supported one. So this is this is the community supported one. So as I talked about, we cut out a new release. So you can go to the releases page. As you can see here, we have like the we release here the conf files, the raw files, and everything. So you see here like the Kubernetes, Sysext for different version and different architectures. We also have recently introduced the NVIDIA one. We got a community PR for the Olama one. And this is just a small snippet of it. There are a bunch of others which are out there on the Sysext bakery releases page. Now going over to the official Sysext images. So this is part of the place where we store our images. So it's on the stable.release.flatcarlinux.net. So if you go there, you will find all the cloud images as well as all the all the Sysext images. So these are the ones that are built during the build process of Flatcar images. Now, heading over to how we plug CAPI and system extensions together. Now, if you have a Kubernetes release, so what we do is that suppose we pick up Kubernetes release, for example, 1.31, and you do all the changes in it. You create a you pull whatever is needed for the release. You add your own stuff into that. This is the part, and then you finally bake an image, and you can create your own Kubernetes Sysext, which right now we do it for you. But in case you want to do more customization around it, you can use the same repo that we have in Sysext bakery and create your own Sysext. Now, once the Sysext is created, you can. This is how we provision a Sysext instance. So you have the distro images, which is, for example, like you have your like marketplace Azure image, for example, like Flatcar there on Azure Marketplace. So you can pick that up, or on the shared image galleries or the armies. You can pick one of the cloud providers which has a support for Sysext. So you use that particular image, and you use the user data, which is primarily, in our case, it's Ignition. For others, it could be different thing, but you basically push the user data config, and you boot the image. During the booting time, I will show you on how it pulls the Sysext from the custom HTTPS server, but it technically is during the boot phase. It pulls the it pulls the Sysext image and places all the binaries into the appropriate location, and what you get is a custom distro instance with Sysext enabled on it. Now, if you remember this particular slide from before, what we had was we had the gallery, we had the Kubernetes version, and the Flatcar, basically the Flatcar Kubernetes image name, and then the version inside it. So this particularly, when we integrate Sysext into it, this changes a bit. So if you see here that the Kubernetes version tie-up goes away, we use the standard gallery image from on Azure during ClusterAPI boot, and we just provide the version number. So technically, we don't have to use a lot of different, so that factor of version matrix goes away. You just use the vanilla or the stock Flatcar image, and we add the providers, which is like, this is the Ignition config. So what happens is that if you notice here that we pass in the URL for, where did it go? Yeah, so we pass here at the very end, you see the Kubernetes Sysext URL. So it downloads the raw file from in there, and it downloads the config file as well, and places the Kubernetes Kubernetes Sysext into the opt extensions Kubernetes. And when the system extensions run, it places the kubeadm and other binaries into the appropriate locations. Now, if you have to open the config file, now one question that I talked of was the in-place update, where currently you really have issues with doing an in-place update for the Kubernetes cluster API images, because you tend to have to destroy the nodes and spin up a new node with the new image. But with system extension, what happens is you can provide through the config that I would like to have a match pattern of 1.31 and any of the future releases. So what happens is whenever there is a new release, the sys update would pull the new system extension file and would run it for you and place the new binaries for you. So technically, you would not have to boot your reboot your clusters again. Now, with this, I think we are slowly getting to the benefits of the CAPI and system extension. So for us, we have started to, we have added the support to Azure. We have added the support to OpenStack. We also have added the support to other cluster API providers. And we are trying to engage more and more providers into the picture, because this definitely helps in less maintenance work. So we have dropped the number of, because anyways, during the release process, we end up pushing Flatcar images to our SIG galleries. So we don't need to have a separate section for pushing new cluster API images into our SIG gallery. So that's a section we can totally drop. And the other good thing is the Sysext that you saw can be reused by other providers as well. So the Kubernetes raw file, image file that you saw, it's the same across all the cloud providers. It's the same image that we use for all the providers. And if you have a custom Kubernetes Sysext image, you can do the same, and you can use the same image in all the different providers. Then the next thing is that we saw is it decouples Kubernetes from the OS layer. Now, the Kubernetes version is not really dependent on the OS level. You can just have the image very different from the Sysext layer. Now, okay, the third thing I already mentioned, which was like reusing the same Kubernetes for different cloud providers. And finally, having a very linear matrix. When we add a new cloud provider, we just add the cloud provider. We already have the Kubernetes Sysext file in there, so we can reuse it, and we almost have the same template. So adding new providers is also super easy. And the update story, which is like having an in-place update with the Systemd-Sysext. And with that, I would like to talk about contributions, because we are a very small team working on Flatcar, and same for, I think, with cluster API providers, where there is, so most of the cluster API provider I have seen, like, it's a very short team trying to work on a single provider. Now, what you can do is that if you would like to create, I would definitely suggest you to try your Systemd-Sysext. If you have a requirement, try to build a new Sysext around it. Like, for example, the LLM one that I showed you, the person was probably playing with it and build an extension for it. And the good thing is it can be ported to all the operating system with support system extensions. And the other thing is, one is from the system extension story. The other thing is, like, most of the CAPI providers still does not have the support. So this is a place where you can probably contribute to and add the support to the cluster API providers. And the other thing is, suppose, for example, like, if you are stuck, you always have the inspiration to pick from the other cloud providers. For example, as I mentioned, the configuration is usually the same, so you can take inspiration on how it was done in, suppose, CapZ or CapV or on Capo. So you can take those inspiration and move it to different cloud providers. There are a bunch of cluster API providers out there. And I think with that, I would like to mention the contribution channels. So if you have any questions, so we have weekly bi-weekly calls. One of them is actually today's, which is the office hours. So we have our office hours every bi-weekly. If you have any questions, we have the Flatcar is there on the Matrix channel, where we primarily discuss whatever development is happening around and around the releases, anything related to the development. We usually end up talking on the Matrix channel, and anything related to user queries, it ends up in the Kubernetes Slack. We are also there on the CNCF Slack as well. And if you want to try out Flatcar, in that scenario, I would suggest that you can look into the tutorial. I'm actually doing a same tutorial tomorrow at 11:30 in the morning. But if you want to take it on your own, you can also look into the Flatcar tutorial. And again, the documentation is also there. So through this, you can, in documentation, we have a more detailed documentation on how you can use system extension, how other OSs are leveraging system extensions, and how you can contribute back to system extensions. So this is something you can also look into. And I think with that, I can wrap up. If do you have folks any questions? Yes. Yeah. So okay, so no, so okay, so the question is primarily just to understand is we are making the providers. You are saying the cloud providers. Correct. Right. No, so Flatcar is a Linux distribution itself, and correct. And so the thing is that, so to repeat the question, so how we replicate this thing to other distributions, right? Correct. 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 So that's the thing. So one thing I talked about is, so usually if you go to the ClusterAPI providers supported OSs, you will see Ubuntu, Flatcar, and few other OSs. Now the key part in here is that the OS needs to support system extensions. So then only you can work on it. And now Flatcar already has the support. And in the beginning of the talk, I talked about this UAPI group. So there are other OSs, because this is a systemd thing, the system extensions. So because it's a systemd thing, so you actually get support for system extension in most of the major distros. So you can actually port this to other distros as well. So suppose, for example, if I take the image file of Kubernetes from Flatcar, it's distro agnostic. You can take it to Ubuntu, and it should run fine there as well. But there might be changes on ClusterAPI side, on the source of ClusterAPI XYZ provider, where you would need to bring in changes to understand that in-place update and everything. So for example, 2 years back, we did PRs to CAPZ, Capo, and everyone for support of Flatcar. Now we are going through each and every providers again to set the support for Sysext as well. So that's how we are working. And the same thing can be replicated for other distributions as well. Yeah. Yeah. Any more questions?
Are you making use of VMverity to verify signatures? Is that something that you're considering for your Sysext?
We haven't. That is something I would need to look into, because that is one of my teammates who works on that. But that is something I don't think we do it for Sysext explicitly. Yeah.
Because that has that built-in. You can give it a VMverity block to verify the signature and
Correct.
have it.
Correct. Correct. Yeah. But I'm not sure. But I can talk with my teammate and get back to you on this one. Yeah. Yeah. Not really. So one of the thing is, since it is pretty new, so the question is, are there any guardrails around Sysext? Correct. So, or the system extension that people are making. Correct. So, given the nature is pretty new, so I don't think there are guardrails. One of the things is you can only merge thing into USR and opt, but there's also not a single way to build your system extension. So people, there are different ways people are doing it. So if you search for Sysext on GitHub, there is one of our repo which has a lot of the ways to create the system extensions. But then there are other repos as well where people are building their own and doing experimenting on their other OSs as well. But there was actually a talk a few days back at a different conference where we were talking on how we can work on to standardize this thing, and probably this is where the guardrails comes into the picture on how much, because the security definitely puts into the perspective on, it's like because you are end of the day you are building a kind of a marketplace, so definitely there needs to be some kind of a guardrail in there. So yeah. Cool. Any other questions? Yeah. So the question is like, will the update happen from 1.30 to 1.30, 30 to 31, for example, right? So at the end of the day, this one that we have is a regex kind of a thing. So we can do that. If you do one dot, it would definitely do a version bump, but it's not recommended. The reason is that there might be breaking changes in between the releases. So it's always, so what we do is that what we recommend is that you do version bumps only, the minor bumps, and not a major bump for a version, because then things might just break, and then you would have to spend a lot of time. So rather, you would spend so how Flatcard works is like it uses the cattle and not pest theory, and so you tear down the whole infra, make changes to the inclination and the config, and then you spin up things again. So yeah. Cool. So, any more questions on this? If not, then thank you everyone for joining, and hope to see you tomorrow for our tutorial.